Hello everybody, my name is Bill Thompson and I am the Executive Director of Alumni Relations here at Embry-Riddle Aeronautical University. And I have the honor of representing over 116,000 of our alumni around the world. We're thrilled to have 3 audiences for this event tonight, 2 live audiences on the residential campuses of Embry-Riddle Aeronautical University. One at our Prescott, Arizona campus, and I know we have a strong contingent there tonight, and one here as well at Daytona Beach, Florida campus. And a special welcome to the hundreds of visitors, students, faculty, staff, and alumni who are watching from around the world from their own space. At this time, I would like to remind our guests that this presentation will be videotaped and streamed live using our Eagle Vision technology. And I ask everyone to please be respectful to your neighbors and turn off your cell phones, or please turn them to vibrate. Throughout the year, the Alumni Relations teams travels the country, engaging our alumni at conferences, receptions, and network events. Tonight, we host the inaugural Lift Off the Page, a lively discussion and in-depth examination of a topic relevant to the aviation aerospace industry and the world. This event brings our alumni, faculty, staff, leading experts, and our students together to learn and share experience on controversial and current topics. Our panelists will explore and discuss the developing unmanned aircraft and autonomous systems industry. Our moderator tonight is Mr. James Roddey, Communications Manager for Embry-Riddle. And tonight's topic, unmanned aircraft systems are revolutionizing aviation. Are you ready? Mr. Roddey, your controls.
Excellent. Thank you, Bill. Welcome, everybody. Those of you out watching this live streaming, wave back to us. Okay, great. Thank you. I can't move real fast because it's kind of a drag there, so that's okay. This is the first, as Bill said, Lift Off the Page, hopefully of many more to come. A free, live, streaming, roundtable discussion, rectangular table discussion, sorry, that invites members of the university community and the public to learn, engage, and share. We've assembled a panel of UAS faculty experts, and you're going to get to know those 3 letters very well this evening. We're going to take this topic from the pages of Lift magazine, and if you have not seen, this is a really, really excellent edition of Lift magazine. If you haven't read the article, I highly recommend you get online and take a look at it, or have Sarah send you a copy. Please be sure to submit a question if you have one. The folks in the audience here have been given 3x5 cards. Go ahead and write them down, and they'll be gathered up and Sarah will get them. If you're online, you can type your question in the chat portal, or any other ways to get to us? Okay. Can't use a UAS? Okay. All right. We're going to have a discussion for about an hour, and at 8 o'clock we'll begin to answer questions from the audience. So I'd like to introduce our panel today. Gregory Sid McGuirk, an associate professor and associate chair for the Department of Applied Aviation Sciences in Daytona Beach. Sid spent 35+ years working for the Federal Aviation Administration in a variety of roles, including air traffic controller, air traffic supervisor, quality assurance manager, staff attorney, and division manager for technical operations training at FAA headquarters. I also want to point out that he has more letters after his name than anybody else up here. Alex Mirot, assistant professor of aeronautical science at Embry-Riddle in Daytona Beach. In May, became the president of the Unmanned Safety Institute, a subsidiary of Waypoint Global Strategies. Alex is an unmanned aircraft systems subject matter expert and former U.S. Air Force pilot with over 3,000 hours in several different aircraft types, including the C-130 Hercules and the MQ-9 Reaper, and taught the MQ-1 Predator. Vince Pujalte is the program chair and assistant professor of unmanned aircraft systems at our Prescott campus. He's also an alumnus of Embry-Riddle's worldwide campus, and he joined Embry-Riddle this summer to lead the UAS program at the Prescott campus. Prior to joining Embry-Riddle, he was an unmanned aerial systems instructor for General Dynamics Information Technology for more than 9 years. Throughout his career, Vince has trained approximately 3,000 U.S. soldiers, sailors, Marines, and inexplicably Australian Army soldiers in the proper day and night operation and setup of tactical military UAS. Dr. Charles Reinholtz is professor and chair of the Mechanical Engineering Department at Daytona Beach. He's been active in developing robotic devices, including unmanned and autonomous vehicle systems, for more than 30 years. Dr. Reinholtz, Charlie to his friends and to us in the audience, holds 2 U.S. patents and has authored a popular textbook and over 125 journal and conference papers in the area of autonomous vehicles, robotics, kinematics, and design. He has co-founded 3 successful companies working in the area of robotics and unmanned vehicles. And I will tell you that his students are working on some of the coolest, most advanced UAS projects in the world. Dr. Richard Stansbury is an associate professor of computer engineering and computer science at Embry-Riddle, Daytona Beach campus, and program coordinator for the Master of Science in Unmanned and Autonomous Systems Engineering. He supported Federal Aviation Administration funded projects to survey unmanned aircraft systems, technologies, and identify regulatory gaps. He supported Embry-Riddle's NOAA GALE project, UAS project, to develop an unmanned aircraft to collect atmospheric data within a tropical cyclone. Richard is leading the university's bid for an FAA Center of Excellence in Unmanned Aircraft Systems under the Multi-University Assure Coalition, and that stands for the Alliance for Systems of UAS Research Excellence. And I know a number of our panel members have been working on that project as well. He's a member of the Association of Unmanned Vehicle Systems International Unmanned Aircraft Advocacy Committee. Say that in one breath. And the American Institute of Aeronautics and Astronautics Unmanned Systems Program Committee. So let's start our discussion tonight with definitions. What's a UAS? What do we mean by autonomous? Define the difference between a hobbyist and a pilot or operator. And then at the end, we'll get to the D word. Alex?
Sure. All right, you want me to do all of them? So, unmanned aircraft system, or UAS, it's not an exciting term, I don't think, but it's one that the FAA has come to approve from a long, basically on a developmental arc here. We started with unmanned aircraft system, or unmanned aerial vehicle, UAV, and we moved into unmanned aircraft system because they wanted to include other components of the system itself. And this makes this a more descriptive term, but doesn't really do enough for differentiating types, and that kind of leads into the next question you had on autonomy. So what's left to answer is, does an unmanned aircraft system have to have a certain level of autonomy, or does it have to have certain characteristics?
And Charlie, you want to expand upon the definition of autonomous, please?
Sure, I'll be happy to, James. So I know we have a pretty sophisticated audience here, I know, because I know a lot of the people here. So to many people this is familiar, but by autonomous, we mean the system can think and act on its own, so it'll have sensors to perceive the world around it, GPS, cameras for computer vision, laser scanners, radar. The information from those sensors comes into a central computer or multiple computers, and the system actually processes the information and makes decisions without a person in the loop. That's autonomy.
Excellent. Vince, tell us about the difference between hobbyists, pilots, and operators, briefly.
Okay. I would say at this point we have an issue where many people who think of themselves as pilots or operators are in fact hobbyists. They're just starting to get into the field. And as the FAA creates a formal regulation, there'll be a much clearer delineation between those groups.
Okay. You get the D word, Richard. Why is it such a negative connotation?
Well, the word drone has a negative connotation because, initially these systems were seen from a military point of view with military applications. So that's one part of it, is people think of almost a mindless, scary, flying through the sky, killing machine, is some of the connotation that people have when they think of drone. More lately, the media has been using the term and tying it to privacy. So they hear the word drone and privacy, or drone and spying over and over again, and it's driven into people's heads that there's something negative about these technologies. And it's also kind of a mindless term. It's a drone. It drones on. It doesn't think for itself. And really what we're developing are very sophisticated systems that have many broad applications well beyond their original founding principles.
That leads us to the next question. One of the biggest challenges to the development of UAS in the United States is a lack of rules allowing for commercial operations. In 2012, Congress mandated the FAA to develop a plan to safely integrate civil UAS into the national airspace and establish operational and certification requirements for public use by 2015. Needless to say, the progress has been slow. So Sid, why is it so difficult to create, adopt, and ultimately regulate this emerging technology?
This is a very, very complex piece of airspace that we live in. Right now, between 5,000 and 7,000 airplanes are up over the United States. When you launch a large unmanned system into that airspace, the liability rises very quickly. And the FAA is mandated to operate a safe and efficient airspace system. And the route that they've chosen to take is to have full integration of UAS into the national airspace system instead of providing blocked airspace or waivers or anything else like that. They want to go in and have a fully interoperability piece with the national airspace system. And so when you look at the regulations, we're not just looking at small SUVs, those that are 55 pounds or less. We're looking at things the size of a 737, things that'll fly up in Class A airspace. How do you control that? What happens when one of those gets ingested into the engine of a 737 and crashes and kills everyone on board? Who's the liable person for that? Are we going to require insurance for operators? There's a whole myriad of questions around UAVs.
So Alex, when we had lunch today, you had some interesting insights into this question.
Well, I think when we talk about regulation, I think first going back to the definition piece, right? When we use and the FAA is going about it with this approach, they're trying to come up with a one-size-fits-all approach for integrating unmanned aircraft systems. What you're hearing from the panel is that unmanned aircraft systems have varying levels of autonomy. They come in different sizes, from something small, akin to a remote control aircraft, to something as large as a 747. And so to take an approach where you're trying to integrate something like that into our complex airspace makes it very difficult. One of the biggest issues, in my opinion, is about how they're going to set standards and target levels of safety. If you look at the traditional aviation community over its history, they've gone and created a more impressive and a precipitous drop in accidents, a very impressive safety structure through a systematic adoption of new technology and improving technology, and then focusing on human errors. Some accounts show unmanned aircraft system accidents at 6 times that of traditional aircraft, and then the human factors aspect of that is much larger than it is in traditional aircraft. So that needs to be addressed. And then lastly, taking a system that could be considered quasi-hobbyist use, and getting those individuals to adopt safety management systems that would improve structures, that's going to be a challenge. So very complex, and to just do this from a policy perspective almost seems unattainable, especially when you think full integration.
So Vince, you just came, were in the private sector for a number of years.
Military.
And in
Yeah, military UAS.
So from your perspective, the difficulties.
I think Alex raised some excellent points. I think it's really difficult to imagine that we'll be able to incorporate everything from small UAS, which could be just a couple feet wide, up to something the size of a 747. I read an article the other day that was put out by NASA, which I thought showed some real insight into this. And they were talking about letting small UAS fly basically within 1,000 feet AGL, 1,000 feet above ground level. And since that airspace so close to the ground is largely unused, and the FAA has some rules regarding that, especially in congested areas where aircraft are not allowed to get within 1,000 feet of the top of the building or 2,000 feet to the side, I thought that was an ingenious approach, because I feel like most of what we're going to see is going to be the small equipment flying.
Interesting. So Richard, you and I were talking just before we started about the ethical dilemmas.
Well, that's kind of a tough and loaded question. I mean, there are, you know, when we talk about I already mentioned, you know, with the D word, that, you know, there's the association with privacy, and you can even get into an easy debate with yourself on this issue, because, you know, you can look at it and say, okay, well, there are existing laws out there that protect civilians from being observed by police, and those laws should, you know, protect us. At the same time, a helicopter hovering, you know, 1,000 feet above is significantly different than a quadrotor hovering 1,000 feet above, and you have, you know, similar cameras. So there is that, you know, that dilemma. However, you're still much more likely to be spied upon through much more conventional technologies than that. I'd say that, you know, the biggest risk for the privacy issues are for people being observed doing things that they don't want to be observed by other private citizens. So not really law enforcement, but, you know, private detectives and things like that. There, you know, it's a different set of laws that have to regulate that, and that, I think, you know, could be an issue down the road.
So Charlie, you have said we ought to be worrying more about phones than drones.
Phones are in the bathroom with you, so that's something to think about. There is another side. There are a number of sides to the ethical issues, but as an engineer, I feel not developing this technology also raises some ethical issues. And we work in ground vehicles and in boats, autonomous surface vehicles, and I can tell you that the automotive industry now, in just the last few years, has come full circle, and they're completely committed to autonomous driving systems. You will see autonomous cars on the road. That's the level of autonomy, the driver assistance. You may hear it described as safe vehicle safety systems, but it's really levels of autonomy, and you'll see essentially fully autonomous cars on the road, I'm sure, by 2020, and they view it as a safety imperative. People are not good drivers and not reliable. We know in the US about 33,000 people a year die in car accidents. A lot of those are preventable, and a lot of those are because we have distracted drivers not developing capabilities that minimize or eliminate those accidents. I think raises ethical concerns. The aviation industry is so safe that it's a very high standard to meet, but I think that same test will ultimately be applied to aviation as well.
Sid, you said you had, at lunch today, you had 3 or 4 examples just pop into your head.
Right.
Share a couple of those with us.
Just over the last month or so, a newspaper article I read talked about some hobbyist who decided he was going to take some pictures of an accident on one of the interstate highways. And the accident was so severe that they had to call in a helicopter to take the injured out. And this hobbyist wanted to take some pictures for the evening news. And so he was hovering around the accident, and the helicopter couldn't get in because of him. And the police officers asked him to take it out of there, and they the gentleman said, well, you don't have control over the airspace, that's the FAA's issue. And
Wow.
the next picture was him in handcuffs and walking away. The other one was the severe fires up in the middle of the state in Washington State. And all of those tanker aircraft flying in with fire retardant. And they had a couple of small hobby type, small UAVs, so 55 pounds or less, that were up there taking pictures for the 6 o'clock news. And had one of them been ingested into the engine of that aircraft, I mean, it would have been a disaster. And then the third one was in Ohio, where a helicopter was going into the hospital on the landing pad, and there was a UAS there, and they had to divert someplace else because they were not quite sure where this thing was going to go. And so there's some irresponsible people out there. I don't want to paint the entire UAS population with that same brush, but there are some folks out there that really don't understand the danger of a small vehicle in the air.
So if regulation is difficult, Alex, you had some ideas on how you begin to do this.
Well, I think the genesis of that, when you talk about on the ethical issue, one issue with not regulating or not allowing for small use of a small unmanned aircraft system use is that what we're seeing is a large segment of the hobbyist population starting to use UAS, and they want to start using this irregardless of what the FAA comes out and says. They want to use these systems to go out and take aerial photography and pictures. They want to sell it to the evening news, that kind of thing. So they see that there's an incentive there, it's economic, and they're going to go out and they're going to do this. And by waiting for the 100% solution, making it to the same level of safety as traditional aircraft or even general aviation, what they're doing is they're just stalling. And in that time, people are getting disenfranchised, and they're getting upset, and they're just doing it anyway. So in my opinion.
And they're going overseas.
And they're going overseas to do it, right? So we do need to get that, and we have to come up with some common sense rules for that group of the population. As Vincent said, we've got this hobby group or quasi-hobby group. We need to come up with some similar rules. Hobbyists already self-govern using community-based standards with things like the AMA. They've been doing this for many years. They're allowed to fly systems up to 200 knots, 55 pounds or less. They do this at designated areas. They have insurance. So there are ways that we can do a systematic approach, especially something that's going to be in visual line of sight. For instance, aircraft can't go or shouldn't be, unless they're restricted category, going below 500 feet MSL, or sorry, 500 feet AGL. So that would allow us to operate small unmanned systems up to 400 feet, not overpopulated areas or near airports. And then we would just have to have a mechanism in which we could communicate these small systems with operations like a helicopter going in and doing something like power lines or dust off, that kind of thing. So I think that there is a way we can systematically carve out. And one thing to do is maybe not approach everything as if it's an unmanned aircraft system, but maybe dividing that up, categorizing that, and coming up with approaches. Yeah, I agree. Highly autonomous systems up high, and there's going to be some technology, see and avoid, sense and avoid type things that are going to have to happen. But down low, when you can use a visual observer, we should kind of start going through. And the FAA, I think, is weighing right now a small UAS rule. We don't know when that will come out. And also some Section 333 to Public Law 112 options, which will be Section 333 waivers that will allow certain types of operations. And then we can get some data, because if we can get some data on safety, we have an unknown, and we're very conservative. I'm talking about from the FAA perspective. So with that unknown, they don't want to do anything. So I think that getting a little bit under a controlled circumstance would help us.
And if I can add to Alex's point, recently the FAA announced 6 UAS test sites, and 3 of them are universities. And so the data is now starting to roll in, just barely starting to roll in because they only announced this about a month ago. But there are 3 universities and 3 states that are going to do some testing of the UAS in the system. And that's a good thing. I think that's progress.
Vince, since you're new to the university and you've been teaching for about a month now, how's the discussion go in your classes? when this comes up?
Well, some of the classes are very large. My Unmanned Aircraft Systems AS220 class, I've got almost 30 students. And so there are a lot of different perspectives on the issues. Something I like to share with the students is the importance of see and avoid and detect and avoid. If there were a standardized system that we could depend upon, that the FAA could depend upon, to keep traffic separated, then I feel like we'd see a lot more rapid progress with the regulations coming out. But I think the FAA is justifiably concerned, certainly, about there being a midair. Although most UAS systems are small, you'd expect the UAS system to be the one that would suffer in that accident. But if there were, in fact, a standardized system or something that was proven that people felt more comfortable with, not only would that protect the folks who are flying in manned aircraft, manned vehicles, but also the unmanned operators. And I think that's the concern that the FAA has. They don't want to be excoriated. They don't want to be seen as being uncaring in the court of public opinion. So they're kind of taking their time, I would think, in the hope that more and more technologies will be developed so that there's a lower chance of there being a midair.
So, Charlie, you've been teaching robotics for 30 years or so?
Thanks for reminding me.
At lunch, Alex compared where we are with UAS to the dawn of flight. And it has a great deal of maturity yet to go.
That's true. And in our classrooms, in the engineering classrooms, it's difficult because the students love this topic. They come to Embry-Riddle, they want to work on unmanned systems, and there's an irony here that we've actually done fully autonomous operations at the Daytona Beach Airport, but with a ground vehicle. We have a fully autonomous Ford Escape, and we scanned the airport. We're doing perimeter scans looking for security breaches. Ironically, we can't fly aircraft. Hobbyists can go out, a student or a faculty can go out as a hobbyist and fly, but as Embry-Riddle, the greatest aerospace and aviation university in the world, we can't go out and fly formally. The regulations are a little bit confusing, and the students are hungry to be involved in this technology, and we're trying to find every outlet we can. But it is a little frustrating that we can't get permission to fly.
Right. We have one whole UAS that can fly, I guess, out of the Eagle Flight Research Center. It's been authorized, but they have to go to special places, right, to be able to fly.
Right. Certificates of authorization are obtained. We're actually, as a private university, not even eligible to directly apply. We have to have a partner that's a public entity, as I understand it. So it's further complicated, and then that's typically a very limited set of circumstances. And so in an engineering context, when you're developing a system, you want to make changes. You're not static. You develop something, you try to improve it, and as the plane or the aircraft changes, you really don't have permission to fly under the same COA. So it is complicated. I respect the FAA is trying to keep us all safe. They have a tough problem, but it is frustrating as a developer.
Richard, this is a question that the Assure Coalition that all of you have helped put together is going to face head on. Tell us about that.
So, well, the FAA has put out a call for a Center of Excellence for Unmanned Aircraft Systems. And they identified a number of research areas that need to be addressed to be able to allow safe operation. And they also have the requirement that you partner with those test sites to do the testing to support this research. And those areas include airport ground operations. So how does the aircraft operate at the airport? How does it identify signage? How does it get from wherever it's berthed to the end of the runway so it can leave? Air traffic management. So now that it's at the end of the airport, how does it take off and successfully enter into the airspace system? For the smaller unmanned aircraft, they've got a low altitude operations research area that looks at the specific issues there. But then there's a lot of different airworthiness related topics such as handling wake and wake separation. There's sensing and communications topics like command and communication. So how does it talk from the aircraft to the ground station or from the ground station to air traffic control? There's also detect and avoid. So how do you see other aircraft and avoid it? Or the flip side, which is often overlooked, is how do other aircraft see you and avoid you as well? So they've got all these various topics out there. Human factors, how do you design the interfaces so that pilots who are now controlling something way off in the distance can still control it with enough fidelity to ensure safety now that they're no longer situated on board that aircraft.
Alex, do you see regulations that will require pilots to have instrument ratings or file flight plans for these systems?
So as we were talking about before, if we looked at it as from 3 different types of problems. So you have this in low, close, small UAS that would be operating away from an airfield. I know that there is some work being done that they're looking at a low-level filing system. Compliance with that might be iffy. So this small visual line of sight segment, and there's a low altitude beyond line of sight segment, and then this higher full integrated larger UAS system, like the ones I used to fly. And I could definitely see instrument rated pilots with commercial licenses, filing flight plans, being on, in fact, it'd probably be much safer for them to be on an instrument flight plan because they would have flight following and they could access the radars. The smaller systems, though, which I think everybody's in agreement that that's the segment of the market that's actually going to be the largest, I don't think that that's going to work. One, you're not going to be able to see those systems on a radar. They're so small and they're very low to the ground.
Unless you have a transponder.
Right. I know that the FAA, when they look at the COA process, they require ADS-B out. So in a future world where we're compliant, where everybody's cooperative rather, we could see that. My worry is that if they make the rules too onerous, these systems are cheap, they're easy to get into, and if the rules are too difficult, people will just not buy into the system. And unfortunately, in aviation, we're used to these systems are expensive, they are heavily regulated, and we have something to lose as pilots, so we are definitely compliant with the system, and we care about safety. When you get a system that costs $1,000 and you come from a hobbyist culture where these things crash, and that's a part of the day-to-day operation, having that group buy into our aviation safety mindset, that's going to be a big challenge. And then asking them to go further than that and file a flight plan, I think it may be a bridge too far.
So there's kind of a feel that FAA is dragging their feet in getting some of this pushed out. Vince?
Well, I think part of it, and this might be an unpopular opinion, I guess, I think part of it is that there are certain, the FAA is a government bureaucracy. And so there are certainly people there who don't want there to be this, this coming accident, because it's going to happen. They don't want this coming accident to occur on their watch. They don't want to be associated with any of the issues that are associated with the accident. So if the agency waits long enough, more and more people will in fact be moving through through retirement, from an active state into retirement, and then they're away from the problem. That's part of it. The bigger problem in my mind, of course, would be that they're just concerned about safety and they want to do the right thing. And when there is this accident, it's going to show up on the national TV news and on all the radio outlets and all that around the world.
Absolutely.
And they want to be able to defend their position, and I understand that. That makes sense to me because I think the FAA is genuinely concerned about safety. I don't think it's just a political problem for them.
Sid?
I believe that that's true. I believe that the FAA is genuinely interested in a safe operation. The FAA, having lived there for most of my adult life, is a rather risk-averse organization. And as you look at the history of aviation from December 17th, 1903 to the present, the safety factors that the FAA, the regulations that the FAA has promulgated, have made this the safest mode of transportation ever devised by mankind. And the FAA is proud of that, and they want to continue that. And they want to bring UAVs and UASs into the system without degrading that safety net. And that's how I see it. Now, I'm probably taking an unpopular position here.
How are politics going to play into this?
Well, they're already playing into it. Right here is the FAA Modernization and Reform Act of 2012. So Congress is already demanding that the FAA move forward. Of course, these are the same congressmen and women who will hold a hearing after the very first incident or accident where there's loss of life. And so that's how politics will play. It plays out the same way no matter where you are.
Any other thoughts on this? Yes, Richard.
Well, I'd say that I would disagree with your statement now versus what I would say back when I first started in this in 2007. Right in 2007 was around the time where the FAA realized that all these different systems were coming into their airspace, they did not have policy, and they shut it down. And that was kind of the big thing that calmed a lot of things down for a bit, and they really did have a strong period of dragging their feet. I think with the 2012 reauthorization bill, the Reform Act, I was actually involved with one of the groups that helped co-author that bill, and that was one of those that was specifically a put their feet to the fire type approach to get them to start moving. Some ways it worked, some ways it backfired. We got all of the mandates, none of the funding, so the FAA now has a lot of mandates to do things and not the adequate resources to actually accomplish those. Fortunately, now that we've got some of those milestones out of the way, they have allowed first responders and people supporting things in the Department of Justice now to have access to do rapid response in the event of emergencies. That's now happening. They met the milestone of the 6 test sites, which are coming online. And now finally they've had a chance to get back to what I think is more important, which is their Center of Excellence, to where they have a pot of money that they can actually bring to this problem that now they can allocate and start doing the necessary engineering to educate themselves and also drive the technology to where we can start getting things done. So a lot of things have happened in the last few years since that Reform Act to really make things happen. They still are, sometimes taking kind of obvious cop-outs. Privacy will come up and they'll start trying to bring that back into their policies. Privacy is not part of aviation and aviation safety. They have to be reminded of that, and usually they listen and then put that aside for a bit. But, I do think things have sped up, and I think it's important to acknowledge that.
Let's take, that's enough on that, eh? Yeah. How y'all doing out there? Still awake? Got good questions yet? Excellent. And you folks out there, just wave and let us know how you're doing. Okay. So let's try another question. I was on the website How Stuff Works, and they had a really interesting article called 10 Non-Murderous Things Drones Can Do Every Day. Oil and gas monitoring, movies, TV, photography, even wedding photography is becoming very popular with the small UAS. Forest and land management, disaster communications and surveys after a natural disaster, gathering data about hurricanes, law enforcement, flying farmers, tracking wildlife. So some of these uses are already in place in other countries, but where do you guys see all of this going in the next decade, 2 decades? Because this is a topic that is not going away ever, probably. Alex, you want to kick it off?
Sure. I don't think it should go away. I think that there's some AUVSI, for instance, put out a report, economic report, saying 100,000 jobs could be created by this technology, and they cited overwhelmingly in that report that the source of that would be agriculture. So agriculture, and we've seen a lot of demand globally for agricultural unmanned aircraft systems. And then I think after that, utilities is another big player. You can almost look at, if you look in the restricted category aircraft and look at down the row of what systems can be certified airworthy under restricted category, it's pretty clear that that's the unmanned aircraft system kind of group core competency. So agriculture, weather monitoring, land management and conservation, maybe aerial advertising, definitely aerial communication hubs. So I think that it's hard to predict where we're going to go, but I know that when I look at demand that's out there, demand is definitely in utilities and in agriculture. And then you said the movies, they've petitioned for 6 studios, I believe, petitioned the FAA under Section 333 of Public Law 112 to allow for small UAS. So and I would never have thought of that one originally. So there's definitely, it's an unknown thing that's going to be the next big thing.
Yeah. I hadn't thought of advertising, but you know there's just going to be you know, things flying around with giant signs.
Well, I mean, you could almost say that the Amazon thing is a giant aerial advertising that never has to leave the ground. You know, so just by the press that they get alone, just by talking about an unmanned system delivering your package, is a form of aerial advertising.
Sure.
Yeah.
So,
Charlie?
Well, you mentioned some excellent examples. I don't think we yet know all of the important applications that these systems will be implemented in. I think the possibilities are endless. Agriculture is a pressing one right now, and flying over a field and looking for crop damage and spraying selectively or watering or fertilizing selectively obviously has advantages. Rather than broadly spraying a pesticide, you spray it locally, you spray it just at the outset of an attack of a disease. Even beyond that, we've done some work in aerobiological sampling, actually sampling air, and the pathogens on plants. When the ground heats up in the morning, the pathogens get carried up into the planetary boundary layer, and we can predict that soybean rust that's here today may be in Georgia tomorrow. So we can really predict widespread outbreaks if we are allowed to use this technology. And I guess I'd like to come back maybe to the safety and liability just for a second to point out that we're talking about systems that in many cases are in dangerous operations, flying over a fire, flying into the eye of a hurricane and trying to collect data. These are places where people are currently putting life at risk. And the liability and safety sword cuts both ways. If we don't implement technology that could save lives, the FAA and the companies that fail to do it could be liable. We see this in automobiles all the time. ABS braking or dynamic stability control. Those are technologies that at first people resisted because they weren't proven to be safe. But once they proved that it was proven that they could save lives, then the same companies that were sued for implementing the systems early on were sued for not implementing them when the data became clear. And that's going to happen, that's going to continue to happen, and it's going to happen in the UAS sector as well. So we can't just ignore there's a safety benefit if we implement these systems in the right way. And don't forget about that.
So, Richard, in working with the NOAA project with the small UAS, one of the things I found that was fascinating was it was disposable. So, talk about that a little bit.
Well, that was one of the challenges of that particular project was there had been some past flights where they were using a much larger aircraft called an aerosonde, flying from the coast into the storm, collecting a lot of good data, and then for the first mission, returning back. Then the second mission, it went out. They were getting such good data, they looked at the insurance policy and realized they could take 8 hours flying home, or they could stay and collect data. So they chose to stay and collect data. The aircraft was lost, and because that was not part of their approved flight plan with the FAA as part of their certificate of authorization, they were more or less grounded. So we had to go with a different route. And the idea now is let's not spend all that time wasted with the ingress and egress, but instead deliver the aircraft to the storm. But now you're delivering it in, way out in the ocean, very small aircraft that has to be able to fall through a very small chute. So we designed it with the idea in mind that it would ultimately terminate in the ocean, and that would be the end of life. So our initial prototypes really had not thought about that end game. As we've progressed, we have started to pick materials that will biodegrade safely and reliably. But it was one of those where it's always an interesting case. You mean you're going to throw this thing out into the ocean and just leave it? Why not get a boat? Well, the cost, and it always comes back to money. The cost of getting a boat out there to find this thing and recover it, it's a big ocean. It might not even be possible. We've had high altitude balloons and other type projects I've worked on for other applications where they've landed in a dry lake bed and it took them a while to find it. So that was on land. That was with a thing pinging, and it was still hard to find. So imagine that out in the ocean.
So, Vince, you heard Sid mention he thought at some point there would be 737 size UAS in the national airspace. Just bringing, can you see a Predator type UAS flying in national airspace?
I feel like the Predator is a proven platform. I don't think we're any longer dealing with issues of reliability for the Predator. And for any platform that would fly in the NAS, in the national airspace, it is absolutely critical that it be reliable. Just to go back for a moment to Sid's comment about larger aircraft, something the size of a 737, I think that we should be open to the idea of that being used for over-the-ocean cargo service, because typically if something were to happen to a large aircraft out over the ocean and it were to be lost, the chances of it hitting something besides water were pretty small. So in my mind, the most logical place to start those type of large operations would be in fact over the oceans, and ideally in cargo service, so we're not risking human life, we can collect data, and we can see exactly how all that works out.
Facebook and Google have plans to launch UAS in the upper, as high as they can put them, and bring free Wi-Fi, or they'll probably charge for it, but bring the internet to pretty much every corner of the world. Do you think that's reasonable? Can it be done? Yes, yes. Please.
Those are typically regarded as atmospheric satellites. There are a variety of ways to accomplish that, and I think that is absolutely doable. Either through using solar-powered aircraft that also have batteries on board to take them through the night. There's a variety of ways to do it. You can use dirigibles. There's just a lot of different ways that could be addressed. Yeah, atmospheric satellites.
Alex, is Amazon's idea of delivering packages a gimmick?
But I don't know if I want to go on record and say.
Or anybody
You
up
may
there.
not get your back.
Exactly.
Yeah.
They'll blacklist him.
I like it. No, I think that there are definitely some safety concerns. To do a widespread autonomous delivery system in a populated area has a lot of issues. I mean, not only do you have to avoid aircraft, you have to avoid people that are jumping up and trying to grab the thing. You have to avoid buildings. That becomes, and then to meet any like FAA target level of safety, I don't even know how you could, it just seems impossible at this moment. But as Charlie said, let's go future 10 years when everybody's in a car that's driving itself. People might get more comfortable with it. And we might build an infrastructure that makes it possible. So I don't see it right now, but that's because I'm not looking at it from the futuristic lens. I'll say that there is kind of on the cargo delivery or small package delivery, the cost is very expensive to deliver something. So I could see something like, for instance, you have a stranded hiker or something, insulin, you need something like that delivered. I could see something where it makes sense to put that cost up front for the delivery of the system, especially in an unpopulated rural area. Like getting my books airdropped to me from a helicopter. Sure, I've seen it on the Google wing project for dog treats, I think it was. So.
AUVSI has said that this technology will unleash $82 billion in economic impact and create more than, as you said, 100,000 new jobs in the years immediately following the legalization of these types of aircraft for commercial use, and not only aircraft, because we'll talk about that. The article in Lift magazine talked about education, leadership, and research in these evolving technologies at Embry-Riddle. Where are we going with this at Embry-Riddle? Charlie, kick us off.
Well, we're heavily invested in it. You see the panel here. I'm impressed by the group that has been assembled and the developments at the university. As you said, we're working in a number of different domains. We have a fully autonomous boat that'll be going to competition in Singapore in just about a month. It's a really great project. A lot of the same technology that you use in aircraft you use in all the other autonomous systems. So I think we're at the cutting edge on this, but I do fear that with the FAA's delays, it's difficult to do the things we'd like to do as a university. So there are concerns.
So how do you move forward with teaching this if there are these concerns?
Sure. I mean, one of the things, and I think it's a little bit on the advantageous side for us because there's not a human inside the system, and we call it human in the loop, but not in the actual system. Some of the things that we would rely on in traditional pilot training or vocational training or dealing with an aircraft, we can simulate. And some of the things where people disconnect traditionally in a simulator from a regular aircraft, where they're like, I didn't get the motion wasn't quite right. There is no motion in an unmanned aircraft system from the GCS perspective. So sitting in a ground control station, these systems fly almost entirely by procedure. I mean, it's very procedure heavy, and so we can really get into, at least on the training side of it, we can look at that. We can do human factors studies on the way that these systems are laid out, and then we can study how these issues affect other parts of the system from the ground. So there is that aspect of it, that we can do a lot. I almost think we can get 80% there just on the ground itself with these systems.
Richard, talk about some of the things you're working on.
From an education point of view, we did launch in the College of Engineering our Masters of Science in Unmanned and Autonomous Systems Engineering, where it's actually a college-level program that takes students from electrical, computer, mechanical, software, computer science, and aerospace engineering, and bringing them into a multidisciplinary approach to look at unmanned systems, air, ground, sea, and space. And one of our areas of concentration is unmanned aircraft. So we've got the education thing covered within our College of Engineering. And then we've already talked about the Assure Coalition and our Center of Excellence bid. But when I was putting that together and I was pulling through the data that we had, I actually had a question come back from one of our administrators saying, is this accurate? Do we really have over 50 faculty supporting unmanned systems at this university? Between Daytona Beach, Prescott, and our worldwide campus, yes, we do. We've got folks all over the country that are doing research and are actively engaged in projects related to either designing these systems, integrating these systems, or educating the next generation of pilots with these systems.
And that leads to another question. Vince, are these systems going to replace pilots?
In many applications, they will. Typically, if you read any of the literature on UAS, you'll come across the 3 Ds, dull, dirty, and dangerous. Things that human pilots, because of our humanity, we may be fatigued at the end of a long flight, we may miss something, maybe something else is happening in the cockpit and we're paying attention to maybe some of the instruments that are telling us something about oil pressure or oil temperature, that kind of thing. That can be a distraction. So I absolutely feel like a lot of what is present manned aviation and expensive manned aviation, not only because of the aircraft, which are larger and consume more fuel, but also because of the pilots who are highly trained and being paid, much more than we're going to have to pay some little electrical device that's flying around in the sky. So I feel like a lot of that's going to be replaced. Something I'd just like to touch on that the gentleman to the left here, Charlie and Richard, have touched on, is our university is the #1 aeronautical engineering university in the world. We've got a great engineering background here. And the unmanned industry is not limited to aviation. There will be ground vehicles, there will be vehicles on the surface of the ocean like Charlie and his team have been working on. I read an article in Unmanned Systems, which is put out by AUVSI, and they said that the banking house Morgan Stanley did a study just on the automotive side of the equation. And they said that in America alone, we would save $1.3 trillion a year in fuel and in reduced damage and costs from accidents as a function of having autonomous vehicles. So I think You know, not only are there money savings, but the first time that someone in their own personal experience realizes that they could have run over some small child or taken the car off the road, and the car corrects it for them, and there's no repercussion from that, nothing bad that happens at all, I think they'll embrace it fully, and they'll be sharing it with their neighbors and with their friends.
Yes, Charlie.
I mean, I just point out too that there's some real efficiency in this. So vehicles, you'll start to hear this if you haven't already, V2V, vehicle-to-vehicle communication. So cars on the road and aircraft will all be talking to each other, talking about intent, and vehicle-to-infrastructure, which is the one that excites me. So when next time you pull up to a traffic light and it's in the middle of the night and there's nobody around for miles and the light's red and you sit there like an idiot waiting for the light to change, there's no reason for that to be true. Cars will be communicating with the infrastructure. If you're the only car on the road, as you approach the intersection, the light will turn green. You'll pass through. The same kinds of efficiencies are going to be had in aviation as well as we develop the next-gen systems. And so there's a lot of benefit to using these systems.
And our next-gen program is already incorporating a lot of this stuff, as well as the Eagle Flight Research Center.
Oh,
Will you
yeah.
let somebody talk about that, Richard?
Well, I mean, NextGen is FAA's approach in automating a lot of what happens within air traffic management so that you can have aircraft fly closer together, much more safely, and improve the efficiency of the system. People get to their destination faster, packages get faster, lower fuel, lower environmental impact, lower noise, take into account, what are the different types of aircraft, how you handle wake separation and things like that. One of the enabling technologies that came from NextGen, ADS-B, is one of the technologies that's being embraced early on for unmanned aircraft, because they can now be built, this big, if not smaller, put on board, and now you have a once per second device that broadcasts out at a known frequency where it's at. That can be picked up by the FAA. That can be picked up by other aircraft. Other aircraft by 2020 are supposed to be equipped with ADS-B for ADS-B out. So at least the unmanned aircraft will know where they're at. Unfortunately, that mandate is not for ADS-B in, so we don't have the guarantee that those other aircraft will know where we're at. So it's not a complete solution, but it is a good start. And that was something that's come from NextGen and the infrastructure that's already been put in place nationwide.
Any other thoughts? Sid?
Well, I think the ADS-B, from a surveillance perspective, will also evolve with the evolution of NextGen. Right now, ADS-B is being used for surveillance over the Gulf of Mexico, which is making the helicopter flights back and forth to the oil rigs much more efficient. Before, it was all non-radar procedures, and now ADS-B they're using ADS-B as though it were a radar. And up in Alaska, we're also using ADS-B in remote areas as though it were a surveillance system. And so I think that as the UAS systems, as the systems evolve, they're going to have to continue to evolve along with the next-gen improvements, and that's going to be expensive.
So what cool projects are on the drawing boards at the university, without giving anything away? Yes, somebody.
Yeah, you mentioned there's a lot going on. I'm sure I couldn't even touch on it all if I tried, but you mentioned the idea of an atmospheric satellite. So this is a system that would be in the atmosphere, unlike a satellite being launched into space, a system that would be in the atmosphere and could serve as a communications link. It's a big application. And one of our faculty, Bill Engblom, has patented a system called the dual atmospheric satellite. It's basically an unpowered system that sails in the atmosphere using wind shear, so that you have two platforms at different levels that are tethered together. And it's a little bit like, it's hard to understand, but it's a little bit like somebody riding on a kiteboard with a kite in the air and a board in the water. Fluids, you don't have two different fluids, but you have fluids, you have the air flowing in different directions, and that's sufficient in most cases to keep this thing aloft indefinitely. It's an amazing idea and an amazing project.
Yes, Richard.
And then I would say another cool thing that we've got going on is Embry-Riddle's participating in the NASA Centennial Challenge for Unmanned Aircraft, the Airspace Operations Challenge, where for us we're doing something unique. Because we can't get access to that airspace regularly, rather than building an unmanned aircraft, we're building an optionally piloted vehicle. So we're taking a Cessna 182 automating it, adding ADS-B, adding radar, and adding cameras so that eventually it can follow a flight plan, avoid aircraft that get within its path, either cooperative, meaning they have ADS-B, or non-cooperative, they don't. And that's one of the other side effects that we didn't really talk about much with unmanned aircraft is these things that make an unmanned aircraft be able to fly around and avoid other aircraft, for instance, as one particular case, that could be moved to your 747. That can be moved to manned aviation and can make manned aviation safer as a side effect. And I think this project's a neat one. We're using this optionally piloted vehicle where the pilot's there just to basically watch things happen, and if, in the worst case, something fails, can grab the yoke and take control. But now that system is an automated Cessna 182, which is pretty cool.
That is cool. So let's take some questions from the audience. This one's from Prescott. A student in the audience is a sponsored competition RC airplane pilot. The FAA has stated that flying RC planes for profit is illegal. Do you think the FAA is overextending its reach and misusing resources? Wouldn't these resources be better spent making safe, sensible regulations? Don't anybody speak up real quickly?
I'll
here.
be happy to leap into
Okay,
that
you
breach.
jump in there.
I think eventually the FAA is going to have to, FAA Modernization and Reform Act of 2012 is forcing them into the 21st century, and they're going to have to ultimately have sensible regulations with respect to unmanned aerial vehicles and systems. There's just no question about that. It's a matter of time. The FAA wants to, I believe that the FAA wants to get it right. I believe that they're also risk averse, and they don't want to see their pictures plastered all over the front page of the New York Times because they had an accident based upon their regulations. We'll get there. If you told me 30 years ago that I could have on my hip a cell phone that could do what my cell phone on my hip does today, I would have thought you were crazy. And so I think 20 years from now, you're going to see the UASs really take off and be a really active part of our national airspace system.
Another question. What would be an adequate insurance policy for a commercial UAS operator? Is it practical or cost prohibitive?
I'll jump in on that one.
Yeah.
So right now, traditionally, unmanned aircraft or traditional aviation, you get hull insurance, and then you'd have liability insurance. There might be other umbrella riders on there. Most insurance companies will not touch hull insurance for an unmanned aircraft system. That's because there's no proven airworthiness. In a lot of cases, the current regulation makes it a public agency that has to fly the system. So having a public agency, they're going to usually self-insure anyway. But I would say future insurance policies that will be written will have to have liability insurance, and they'll have to have some personal liability insurance as well. And that's dealing with a little bit of the privacy issue, because we're going to have people suing that are saying you invaded my privacy. So that's going to be a big part of those future insurance contracts. The second part of that question is, does it make it, does it kill the industry? If you're flying a small quadcopter and you have to get $1 million insurance policy, your business model, you're going to have to charge a lot for those aerial photography, for that aerial photography. And it may be that it's cheaper just to rent a manned aircraft. But that we have to start, and the insurance companies are going to have high policy rates because there's no data to estimate their risk. So right now, I'll give you a big number. If that doesn't scare you off, come on in.
So if a hobbyist does something bad with their little UAS, who's liable there?
Well, so the AMA, which is probably the largest group that helps hobbyist aircrafts, that's the Academy of Model Aeronautics, they offer insurance. For hobby recreational use, it's a different liability than it is for hire. If I'm charging you money or I'm a hobbyist, that's a very different thing. So that community self-insures. And I think the previous question, they're like, is that a waste of resources? I don't think it takes much resources for them to come up with a policy. And I also think it's the first step in they have to define what hobby is in order to define what commercial is. And so nobody's even looked at this for so long that everything was kind of okay. You could go out and you could be do an exhibit with your hobby aircraft and charge a fee for that, and that was okay. And now the FAA is saying, oh, wait a minute, we're going to apply the same logic that we do in aviation. If this is for hire, you're a commercial pilot. If this is incidental or for recreation, you're a regular pilot.
May I say that the U.S. Airways incident up at LaGuardia, where Captain Sullenberger put that airplane beautifully into the Hudson River, was down by 2 geese that were less than 55 pounds. They didn't have insurance, but, but let's put a small UAS into the air and have it ingested in an Airbus's engine and have it go down. No one was even seriously injured in that accident, but that was a very, very wonderful piece of airmanship on his part. And so the $1 million, if you down a 737 filled with people, is the airplane itself is in the $20 million range. And then all of the people who died on board that aircraft, the lawsuits are just unbelievable. And so $1 million isn't even going to touch it.
No, I agree.
Not even touch it.
Interesting. Richard, would being a part of the FAA Center for Excellence allow Embry-Riddle to test UAS legally?
That's an interesting question. So, if we were to become a member of the Center of Excellence, that would not change us and our status as a private institution. It would get us access to, for FAA-sponsored projects, one of those test sites, where either we'd be operating them or somebody at the test site would be operating them on our behalf. However, one of the great things about working on a proposal that's got 13 different team members is you just start developing really good friends from around the country. We've already had a number of public universities state outright that they'd be willing to sponsor us if we need to get a COA for future applications. So I think that we do have the opportunities now in hand, given the right options to do that. We still have to work out with them, you know, the liability issues, the transfer of equipment issues and stuff like that that comes with having somebody else sponsor a certificate of authorization. But I think that, you know, even if we don't become members, it'll be, you know, even if we don't get awarded this center, we've already got a lot of benefit from it. But I think if we do get it, having access to those test sites through this channel would definitely help us. Though, I mean, we've also got, you know, opportunities that are emerging within the state of Florida that over time, hopefully we can leverage with, you know, efforts down at Kennedy Space Center and the like. It's, again, everything's emerging very quickly. The small unmanned aircraft rules, as those come forward, could significantly change when and where we can fly. So a lot of this is kind of a wait and see kind of time.
Vince, a Prescott question.
Okay.
At the moment, Prescott just offers a minor in.
Yes.
So what is Embry-Riddle's plan, or what, I don't know if you can answer that, for the UAS program there, and what opportunities will this bring, and what experiences will it provide?
It's an excellent question. The university worldwide, Daytona, Prescott, we're all immersed in UAS. We're all very interested in that. We presently do have a minor, as you pointed out. We have submitted to the university structure here, as I understand it, the request and a business plan to be awarded a BA, or BS I should say, I suppose, in UAS at Prescott as well. So we intend to have the same kind of structure there is here at Daytona, where there are 2 tracks, one which is a pilot track and one which is an operator track, or operations track, I should say. So there's that. We also, last week, received from Vans Aircraft in, I believe they're in Oregon or Washington. Is anybody familiar? The great manufacturer of the RV line of homemade or amateur-built aircraft. And they shipped us an RV-12. And like the 182 that Richard mentioned, we're intending for it to be an OPA, an optionally piloted aircraft. So it will not only be constructed by students with faculty advisement as a true flying aircraft, not just for people, but also to have sensors and so on it, so it can be used as a UAS. That's our goal. So we're moving forward there as well.
A master's in UAS.
Yep.
So it's expanding a lot. How big of an issue This is from an alum. How big of an issue are bandwidth limitations for large UAS beyond line of sight?
It's going to be an enormous issue. So,
Does there have to be bandwidth released by the FCC?
well, the spectrum is actually very crowded. And then if you're thinking, we're typically in the KU band, some work in the KA band for beyond line of sight systems. Now, one thing with autonomy, and I think this could be a solution, there's nothing that says that it has to be hogging all that bandwidth while it's moving. Right now, military systems like to have that bandwidth so that they can conduct intelligence, surveillance, and reconnaissance mission. They have to see the imagery. But if you have an operation where you're going point A to point B, or you're collecting data that can be processed after the mission lands, there are ways in which you could limit the bandwidth use. I know there are systems, I mentioned the Aerosonde, right? It uses the Iridium network for beyond line of sight. So it uses a whole different established bandwidth. So there are solutions. I think if you get to a level of air travel for unmanned systems that you have for traditional, yeah, there are going to be huge issues. I mean, even at 2.4, which is what a lot of the small systems like to use, it's a very crowded bandwidth. You get multiple systems out in the same area, and you're going to have crowd out. So, anything you guys want to add on that?
Well, I know that the, kind of again going back to the FAA Center of Excellence, spectrum management is one of the identified research areas. So the FAA is aware of that, and it is a concern. And that was talking about figuring out what are the needs, and then going to the World Radio Congress to then make the necessary requests to get that allocation. Similarly, the FAA works with the RTCA to do basically industry-generated standards, and they have a special committee, 228, that has 2 tracks. One is detect and avoid, the other one is command and communication, and that group is also working at trying to figure out what are the requirements so that then they can do the necessary next steps to ensure that we can meet those requirements.
One last thing on that one. In addition to allocation of spectrum, security of
Yes.
command and control links is a big issue. So right now we're kind of operating in this world where we have open links and everybody can freely use them, but there will be, I don't want to say hijacking, but you could definitely take control of another system if we don't establish security and encoding and deal with that. And that'll be an issue as well. Yeah.
If you don't mind, Jim, I'd just like to mention something about the hijacking. The University of Texas did a study where they were looking at what's called spoofing, such that when an aircraft is in the air, someone can in fact hijack it. There's a variety of ways to do that. The method that the University of Texas at Austin pursued was they had a small UAV in the air, and I believe this was in the main football stadium there. And they provided it with a signal that was accurate, temporarily accurate, that was stronger than the present signal. Once the UAS system assumed that the stronger signal was correct and locked onto it, then they were able to change the parameters and make the bird do whatever they wanted it to do.
That's a little scary.
So there's a variety of ways to attack it, to hack into the system. We have concerns about spectrum management or frequency deconfliction here, but as we look at operating these things different areas of the world, that's a whole different concern with the World Radio Congress and other things that Richard mentioned.
Yeah.
So it's more complex than just having a simple answer.
So when I buy my first hover car, who's going to regulate that? How does that work? Come on.
The FAA would handle hover cars.
The FAA regulates everything,
That's right.
from the ground up.
That's right.
You can drive it indoors.
That's right.
Indoors.
Yeah.
All you want without a license.
All right, so I want to give everybody a chance to kind of give me some final thoughts. We're not going to get to all the questions, but you can send them to liftmag@erau.edu, and we will get back to you on that. And then we're going to forward them to all you guys, and you're just going to spend hours and hours answering these questions.
What an opportunity. Thank you.
Yeah, I'm sure you'll come up with some great ideas. So, final thoughts. Sid?
I'm honored to be on a panel with such distinguished scholars, and thank you for having me.
That was way too short.
That was a good one.
Alex.
Yeah, I thank you as well. I think that one of the things that will be part of the political issue, part of the regulatory issue that's going to be interesting, and one of the areas that I'm most interested in is coming up with what will be the requirements for the operators and how humans will stay a part of it. There's definitely groups that are lobbying to make sure that a human is always in the loop. I think that makes people more comfortable as these systems start to fly. We talked about in the beginning the drone word, and I think one of the connotations that makes people uncomfortable is the thought that there's something without any, even if it's safer, which is the interesting part. Even if it's safer, they still feel worried about having a system without somebody in the loop or at the controls or supervising it. And so what will that certification level be? What will the requirements be? One thing that I look at is, and there's definitely an element within the hobby group, they might be very good at flying a system and they might be very skilled at that, but buying into the airspace structure, buying into Part 91 and the FAA rules, what is the FAA going to require? I think that's going to be very interesting as that kind of gets hashed out. If we look at the COA process, they start to kind of tip their hand on that one. And if you look at that, it's they want even in Class G airspace, private pilots with crew resource management and safety management systems with risk analysis, which makes sense from their part. It absolutely does. But that's a lot. That's a lot of requirements. That's more than I need to go get as a sport pilot, jump in the plane if I'm operating as a sport pilot, recreational pilot. So, or if you think of ultralight vehicles, I can go get into a system, 256 pounds, go fly around and yield it right away. I don't need anything. Valid driver's license.
Wow.
Yeah. So, what are they going to say? And is it going to be so onerous and such a high threshold that people just say, well, you know what, I'll just buy a system. So I don't envy the FAA at all in what they're doing.
So could the small guy be left out when the regulations are...
Yeah, if they go with a heavy regulatory hand on this, what could end up happening is they could leave them out and they could end up squashing 80% of the industry. So the market for the large systems will be significantly small for commercial. Governmental may be larger, or governmental type agencies that are working with governments. But yeah, they could definitely be an issue.
Vince?
I'd like to thank the university for having us as well. I think this has been really worthwhile, and it's also a thrill for me to be among such scholars. There's a concern, I think, a legitimate concern among the pilots, or among the public, I should say, regarding privacy issues. If you one night hear something tapping at your window and you look over and there's a quad rotor there tapping against it gently with its lights flashing while you're watching TV, you might think, wait a second. I read a bumper sticker the other day that I thought was kind of insightful regarding this, and it said 1984 was supposed to be just a work of fiction, not a manual or a guidance manual for how to run our government and how to run modern life. And I thought that that was pretty insightful, because people are genuinely and legitimately concerned about privacy issues. They're concerned about ethical issues. They don't like the idea of something showing up that doesn't seem to be guided by a human hand, that can impact them and rob them of something that they've taken for granted, their privacy. I think that's legitimate. See and avoid, I think, is going to play an enormous role when that technology is ideally standardized, so that operators can, in fact, keep their craft away from other aircraft, either manned or unmanned. An instrument rating makes sense to me to have flight up in the flight levels, up in Class Alpha airspace. And I think that UAS should require that, that the FAA would be absolutely justified in saying if you're going to fly this up in the flight levels above 8,000 feet MSL, that it's reasonable for you to have an actual license, including an instrument rating.
Mm-hmm. Charlie?
Those are some great comments. I want to make sure there's no impression that we're sitting on our hands here. There's a lot of activity. Alex has been working with local law enforcement on a certificate, and has a certificate of authorization. our teams do get to fly. We send a team, usually multiple teams, to Pax River every year, and we get to conduct autonomous flight operations, fully unmanned autonomous flight operations there. We've had a couple of demos this last year down in Kennedy Space Center. We're taking every opportunity to get up in the air, and I think we're trying, as Alex mentioned, we're operating in simulation. We're working on the other systems, ground systems, underwater autonomous vehicles, surface vehicles. We're doing everything we can. I think the important message here is that hobbyists are going out and flying. A lot of people are getting into this game. Embry-Riddle needs to be the lead in this, or one of the leads, and it only makes sense. We're at this great university. We have all these resources. There are clearly technical experts here. We are concerned about the ethics and the privacy concerns of using these systems. We just have to be involved with this. So it's not a perfect world. There are going to be mistakes, but I hope we can keep those to a minimum, and I feel really confident that Embry-Riddle being at the lead in this will ensure the safest and the most expedient implementation.
Richard.
All right, well, again, thank you for having us here. This has been great. You know, I don't want to leave people with too much of a pessimistic message regarding where we're at. We talked a lot about regulations. We've talked a lot about privacy concerns and stuff like that. But just in the few years that I've been in this industry and working with this industry, it's amazing to see how it transformed. The first year I went to AUVSI back in 2009, the trade show was so focused on what you'd call drones. There were, you know, Global Hawks, there were Predators, there were things that were meant to carry tactical weapons or ISR things. It was, you know, very focused in that domain. This year, the biggest, hottest booth was the AR drone Parrot booth, where they had quadcopters dancing together. We had, last year, the movie industry was there, and they showed scenes from the movie Skyfall that were filmed using a man-controlled but remotely piloted helicopter following Daniel Craig as he went over the Grand Bazaar on a motorcycle. And that was all stuff that was done with technologies that before would have been a helicopter, and you wouldn't have been able to capture that kind of thing. So there's lots of cool things happening. There's lots of innovation happening beyond the regulatory side of things. And so we're actually at a very exciting time. Hopefully the FAA makes some progress, embraces the smalls, because the smalls is where a lot of the exciting stuff is happening. That way we can, you know, keep this thing going and get people engaged, get the public engaged. People can now go and buy an AR drone at Brookstone, not an advertisement, just a fact, and go out and fly an unmanned aircraft immediately off of their iPad. I want that to be, you know, a trend, so long as they're small, they're safe, they're foamy, but I want people excited about these things because they're fun.
How small can they get?
Pretty small.
Real small.
Yeah, there's some DARPA work where these are dragonfly sized or even smaller than that. It's pretty amazing.
The British Army is using one called Black Hornet, which is smaller than your hand that can fly for 20 minutes, and it's a true helicopter. It's got a camera on it. It's amazing.
Anything else? Worn you out? This has been a great discussion, so thank you. How about a round of applause, and you folks out there at home, a round of applause as well. I wanted to mention something about, but I'm still going to mention it. We have a wonderful professional program at Embry-Riddle, worldwide and both campuses. And there are upcoming unmanned aircraft workshops coming up. One in Daytona Beach, December 9th through the 11th. One in Las Vegas, January 29th and 30th. And one in San Diego, April 2nd and 3rd. So if you're in the industry, if you want to learn more, I would suggest contacting Sarah Oakes at the professional programs and finding out about that. I think we are at a good point to say, I appreciate everybody. This was a fantastic discussion. I think we solved most of the problems in the industry if the FAA had just been listening to us. So, and Bill, come on back.
Ladies and gentlemen, I'd like to give one more round of applause to our panelists for taking the time to be here. These events are never easy. When you pull them together, they become a vision. And I'd like to make a special thanks to our sponsors, the Embry-Riddle Alumni Association, the Office of External Relations, our faculty experts, our moderator, James Roddey, Office of Marketing and Communication, which really made a big difference on tonight, and of course, technology, as we look at information technology and logistics support. So this was our first. It went very well. There's always a few glitches as we look at things, but we're very pleased with what took place. From a show of hands, which I cannot see through the video camera, but in this room, how many of you would like to see another presentation done like this? Very good. Woohoo! By the way, it's unanimous if you're listening out there. In addition to tonight, there's a couple extra people who have really made a difference, and I have to say that, I have to name them. It's always questionable when you name, but I'd like to name Ms. Stephanie Hash, who's the administrative assistant with Alumni Relations, who helped us bring this together. From the Office of Communications, we look at Melanie Azam, who also helped write the Lift magazine article that you might have seen in there, and also Alan Caesar, who also supported us on the internet as well. And you look at Lift off the page and you look at Lift magazine, Sarah Withrow is our editor, and she doesn't like to have this public acknowledgement, but I'd like to give it to her right now. Sarah, if you can stand. So thank you for an entertaining evening to all of our guests, near and far, and we look forward to hosting another event wherever you are in the coming months. And most importantly, thank you to the panel, to James for stepping in. We have a gift which we'll be giving our panelists, which is a commemorative issue of our tabletop book for you to remember Embry-Riddle. And it gives aerial shots of the campus as well, so you can always see it from the air, but I have a feeling you have other ways to do that. But most importantly, to all of you here, our students, our future alumni, our visitors and our friends, but especially to our alumni, thank you for being forever an Eagle, and thank you for everyone for participating in our first inaugural Lift Off the Page. Thank you.